Hi there, everyone. So we'll continue the series of harmonic motion, and today we're going to derive the equation for a simple 1-degree freedom system. So here's a mass m that's connected to a spring, and it's free to roll. Let's do that. It's free to roll, basically, and that means no friction. So we're basically ignoring friction. And spring constant K, let's define our axis of motion. Point. Okay, so so basically we're going to derive, our goal is to derive the equation of motion. So the first step we do, so let's draw the spring alone first. Okay, so use a different color here. So you got to understand that this here is basically, yeah, let's do that. So, oops. This is the original length of the spring. So LO is original, or yeah, original unstretched length of spring. And then here, this is the displacement x that the cart or the mass moved. And then the whole thing, that's called the stretched length. Okay, so we got that down. Let's move on to, so first let's just write, okay, so the stretched length, that's basically LO plus X. Okay, let's draw a free body diagram of the mass M. Now the force of the spring is trying to pull the mass backwards. So the force is in tension. So we draw the force that way. And now we have, so that's the direction of motion. That's your positive x-axis. That's your acceleration, velocity. Oh, that's excessive velocity acceleration there. Okay, so we're going to use Newton's second law of motion, which is F equals ma. Basically m times the mass times the acceleration. So we're going to sum the forces of this system here. Sum the forces, where you consider this direction to be the positive. Sum of the forces, so m times the acceleration is equal to, that's the force of the spring, so minus F spring. I'm going to turn down this brightness of the screen. I don't know why it's doing that, but Oh, that's too low. Oh, okay. So that's a lot better. Okay. So we've got the force of the spring down, and from Hooke's law, we know that the force of a spring is equal to kx, x being the displacement. Okay, so rearranging, we go mx double naught. We're going to bring the force to the other side of the equation, so it's going to be a positive Fs equal to 0. So rewriting that again, m equals x dot dot plus kx equals to 0. That's your equation of motion right there. That's as simple as it gets, equation of motion. That's the simple equation. From here, from this equation, if we divide the entire equation through, plus k by m, so divide through by m, we'll get plus k over m. So this here, this baby here is your angular frequency squared. Angular, let's do that. So this is angular frequency. That's an important equation that you should know or memorize for life, basically. Thank you, and that's the end of the video.